Hi, everyone. So I'm super excited to be here at Next Conference 22 with you to talk about TechBio. I think we are living right now an exciting time because we have the ability to have access to very key important technologies that are driving the way that we are interacting with each other, the way that we are communicating with each other, but also the way that we are defining ourselves as part of human being, and the way that we're thinking about what's coming next. So TechBio is actually one of the most important paradigm shifts that there is out there right now. And as I put it, it's all about the coming age of what it takes to actually redesign and re-engineer life. So let's start with a little bit of, basics. What is TechBio? And is TechBio the same thing as biotech per se? Well, no. TechBio is not actually per se biotech. We are calling TechBios all the companies that are actually biology companies, biotech companies, but that actually use computing technology as the core of the product developments. And so if you really think about it, tech is something that we've seen evolve over the past 20 years to the point where it's actually embedded into our day-to-day life, thanks to the advance in computing, in AI, or machine learning, in quantum computing, in cloud services, most importantly. We've been able to have access to recommendation on what to buy, what to eat, what to look for. And we've seen how they've changed tremendously. Now, on the parallel track, we have a long-standing technology, which is actually the life science research. And so in life science, it has given us everything that we know, from vaccine helping us actually address pandemics, but also long-standing disease such as polio, addressing chronic diseases such as diabetes, but also addressing the issue of aging. Now, over the past 10 years, what we have seen is actually these two tracks converging together to create a new kind of companies that are actually using computing technology to leverage the development and research and development in life science. So why is this happening now? And why actually is TechBio actually exploding as it is? Well, you all know about the Moore's law, that law and principle that have made electronic costs go down so deeply so that right now, any one of us in this room actually have a cell phone in its hand and the ability to connect to that cell phone. Well, that cell phone in itself, it's actually a piece of electronic that is more data point and more actually advanced electronic than what was actually used to put a man on the moon. And so if you really think about it, the only reason why we are at this stage is because of the economy of scale and the cost structure that allow for this to happen. Well, this is exactly what's happening in biology. Over the past 20 years, there have been a major acceleration in technology linked to genome sequencing, taking the prices down from 100 million in 21 only to putting the price tag for genome sequencing to $1,000 per genome. And so, thanks to that, we have seen that DNA and protein sequencing and synthesis have been exploding, allowing for a growth of molecular data. With that molecular data, we have been able to use the advances in cloud and AI and quantum computing to be able to analyze the huge amount of data generating, but also start actually using this data to make prediction on potentially understanding what are the patterns of the mechanism working behind diseases. And we have also seen a trend where the acceleration in lab automation and robotics has allowed us to actually run through this run of experiments much, much, much faster than what we used to do before. And so, if you're going to think about it, what's happening in biology converging to computing is actually exactly something that we have already observed, because we have all seen the power of what millions of data points can bring to us in terms of disruption. If we are able to order a cab right now at the tip of a finger and then be able to know at what time we're going to arrive at the airport on our way out, if we're able actually right now to a recommendation engine telling us what are the kind of movies that we might be susceptible to like more, this is all because of these millions of data points that have been created over the past 10 years and that we've been able to exploit over this computing technology. And so what is missing right now to biology is actually the same paradigm shift.
I was trained as a physicist, but fascinated with computers. After my PhD, I had my own individual aha moment of, what if we could program biology in much the same way that we do computers by using the rules of physics to do that?
As a postdoctoral fellow, we were working on trying to understand how the immune system works, and the field of synthetic biology was in its very early stages. You could build a piece of DNA that when you stuck it into a bacterium would cause the bacterium to turn on and off in like a rhythmic blinking fashion.
I think what's special about synthetic biology is over the course of the last few decades, our ability to reprogram the living world has really accelerated. But then biological systems do so much more. What's so cool about biology is it not only knows how to program, but then biological systems can make stuff like fuels and alcohols, medicines that we use like insulin, and laundry detergent enzymes.
Synthetic biology is really about using biology's way of making molecules to make molecules biology never knew about. We've built a community here with many faculty, hundreds of students and researchers that define us as the destination for work and research and study in synthetic biology.
My lab focuses on the cell membrane, the structure that surrounds every single living organism. And what we're able to do is actually build the cell membrane in our laboratory from scratch.
In my lab, one of the applications we're most interested in is using this idea of a cell-based device to treat cancer by coaxing the immune system to recognize a tumor and remove it safely from the body.
I have a brand new collaboration to use biology to help degrade plastics. We want to eventually be creating plastics that are degradable on command.
We've been studying for a long time how molecules sense their environment. What we figured out how to do is take lead-sensing molecules out of the bacteria and put them in a test tube. So now someone that wants to sense for lead can dip this piece of paper in the water and they see the spot.
I think we're kind of at this tipping point in the field of synthetic biology. It's going to impact us in our lifetime, right? And it's not going to be in 20 years or 40 years or 100 years, but it's starting today.
Wow. So the idea behind, as you understand, is really to apply the principle of engineering to biology. And the paradigm shift is to actually see the cell as a software, as something that we can actually program. And so bringing actually software to biology comes with the idea of using the same design, build, test principle that we have been used to apply in software development to the entire ecosystem of life science research to allow us actually to bring lab products from lab to market. Just to give you an idea of what that means and what that represents, you need to understand that thanks to the huge shift in DNA sequencing and synthesis, we have seen a production of a huge amount of data. And for example, in 2021, the UK Biobank is generating the whole genome sequencing of more than 200,000 individuals alone. That's actually the largest whole genome sequencing database that has been created to date. And they're planning to add more than 3,100 whole genome sequencing data to that alone by 2023. In the US, we have what we call the All of Us project. We each intend to actually bring the data of whole genome sequencing of more than 1 million Americans. So what we're living in is actually very specific, and it's actually a very disruptive area, because this is going to be the area where we're going to be able to have precision medicine, where we're going to be able to use the ubiquitous aspect of precision medicine to be able to develop drug that is genetically engineered and fitted for each one of us individually. So we're talking about putting and bringing software to biology. And we've seen that we want to apply this same design, build, test principle to biology. But how do we do that? Well, historically, when we think about biology and companies in life science research, we have always looked at things in a very vertically integrated way. When we think about companies, we're thinking about companies that are going to cover the entirety of the stack. That's what it takes to bring that product from lab to market, and they do it all by themselves. What's happening with TechBio is actually entirely different. If you think about it, there is two components that are actually very important. First, companies are shifting from being vertically oriented to being horizontally oriented. So instead of actually being the one that are going to produce everything, every element, and every aspect of what it takes to develop a drug or build a product and take it from lab to market, they are going to be niche. They are going to specialize on what we call one of the tech stack required for TechBio. And so you're going to find companies that are now developing either at the raw material layer or either on the all subsequent layer. So let's have a look at what are these new layers and what this new tech stack for biology represent. So right now, instead of trying to develop entire product on the whole vertical area, companies actually start to develop on the raw material layer. And the angle for these companies are actually to build the capacity to actually sell and produce bioproduct. And so you have different kind of companies, such as Twist Bioscience or even BitBio, whose sole purpose is actually to produce. So they can have and use different type of technology. Twist Bioscience, for example, is a silicon-based DNA synthesis. Some of them specifically will specialize on producing only DNA, while some of them actually specialize in protein engineering. It doesn't matter. The only sole aspect and sole purpose of these companies are actually to produce the basic components that are going to be used by other companies. The second layer is actually the one linked to product development. Because if you really think about it, these researchers that are now facing new paradigm and new way to actually build biology product need to actually go through the hassle of having to design this new organism. Because we're talking about not just waiting for the experiment to tell us what we want to know about a disease. We're talking about the idea of taking control and then specifically engineering organisms that fit one specific function. And so in order to do that, now scientists are using new set of tools, the same as you are using an IDE in software to actually build your software. It's the same we have now actually some sort of IDE for specifically engineering and designing organisms out of scale. And so depending on the positioning of which one of these companies, you can have companies that will actually manage the entire process of designing actually a full entire organism, from protocols actually that are being shared in between researchers to actually sharing design and allowing researchers actually to work in a collaborative way around the design of this organism, to actually gathering the data coming out from the experiments themselves to be able to perfectioning better on these designs. The next layer, once you actually have your building blocks and that once you have actually software tooling that allow you actually to use these building blocks to actually build and design the organisms, actually the companies are going to be responsible for manufacturing these bioproducts. because there is a difference in between being able to produce actually the basic component that you need, whether they are actually DNA or protein. There is a difference in between being able actually to use tooling to be able to design your organism. But once your organism is actually designed, you're far from being over. You're far from being done, because you actually need to produce and manufacture it at scale. And as we've seen with the COVID vaccine, it's not an easy task, because actually we building entire bioreactors that are going to be able to produce at scale in 1,000 liters and more, the actual bioproduct that you have actually sought out and designed is actually a real challenge. And so on this alone, you have a lot of companies that are going to be coming into the ecosystem to support the production and the biomanufacturing of this product. The last almost, I would say, layer before the final actually end user layer is actually the regulatory layer. Because we're talking about biology here. We're talking about elements that are going to be impacting our life, elements that is the component of who we are. And so, as you know, biology and life science in general are actually heavily regulated. And for startups, it's most of the time actually one of the elements that are going to prevent them from going from lab to market, because they have to fit to the regulation, whether FDA in the US or EMA in Europe, and they have actually to assess the quality of the production and give reporting on the quality of this production. And this is where actually having not a vertical-oriented, but a horizontally oriented stack layer for biology makes sense. Because you cannot expect from each one of the startups actually developing bioproduct right now to have to deal with all of that. Why should a company have to, all by itself, produce the component that it needs through the DNA or protein, then have to assemble it through a team that is going to be able to be expert in designing organisms, and then have to produce at scale and manufacture at scale this product, and then have to deal with the regulation. This is the old way that we used to do things, but as we know, it didn't work out as efficiently as we would have liked to, because this is giving us actually research and development life cycle that actually lasts in between 7 to 10 years and costing us billions of dollars. And so what we observe here with this new TechBio stack, where instead of having heavily vertically integrated companies, but where we have companies working at the horizontal level that allow each one of the companies to actually use the piece of technology developed by other companies, allow us to move faster. The same way as in computing, we actually moved away from having a own data center on-premise and having to manage ourselves our own server, our own stack layers, to actually consuming pieces of software in a cloud fashion way that allow us actually to build product faster. Because at the end of the day, the product is what matters. And as I used to say to my developer, we're not here to be king of the developments. We are here to build product. And so in that spirit of building product, the last layer in the TechBio stack is actually the end user layer. And this is where you found companies like Moderna, which has revolutionized actually the RNA technology and use it to help us in the fight against COVID. But you also have companies that are not just only drugs and therapeutics, because the power of synthetic biology makes it so that we can actually change every aspect of our life. Synthetic biology impacts everything that we consume and that we produce. And that means that we can find out companies like Perfect Day or Meatable that are in the agriculture and food industry and that produce actually alternatives to byproducts, animal byproducts, and alternative to dairies. And so what is this in terms of opportunity? Well, TechBio, beyond TechBio, we have what we call the bioeconomy, because as I was explaining, it's about everything that we consume and produce. And as it is, the bioeconomy represents a forecast of more than $4 trillion at the global market level that will be reached by 2030 and in between 2040. And so there is the ability for us actually to change our world, but for that also we need a shift into the entire ecosystem. And that means that from an investment perspective, we need to switch gears. We need to switch gears to the traditional way of funding companies, where we are actually used to funding companies that are actually vertically integrated only and that consider the entire value chain of the product development as under their responsibility, to shifting gears to investing more and more into this, what we call bio-platform. These bio-platforms are the future of technology in biology because they understand the power of the ecosystem. They understand the power of developing at one horizontal level and becoming actually a software, a piece of technology of reference to other service providers such as like them. They understand where are the places in the TechBio stack, whether it is at the raw layer, whether it is at the software layer, at the manufacturing layer, or at the regulation and end-user layer. And so there is a shift right now in the VC industry into new kind of investment firms that are now trying to support this new type of companies. And so to give you an idea, when I started in 2018, we set out with the idea of trying to help companies address the issue of managing data in their research and development process. At that time, I was actually working with a company, small startup, actually in developing diagnostic device for Alzheimer's disease. What they were trying to achieve was fairly simple. What they wanted was actually to be able to predict 5, 10 years onwards if someone, based on their blood biomarkers, was actually going to develop Alzheimer's. Now, when I joined the company, it was a very fairly task and set of tasks. I was actually brought in because of my computing abilities, and I was in charge of actually developing the algorithm that would be able to support that device. But very quickly, what I realized was that there was no way for a computer scientist to be able to develop a software and not an algorithm that we're going to be able to predict with 99.9% accuracy that someone was going to develop Alzheimer's disease. And the main reason why was basically because these data points were not what a computer scientist will consider usable, interesting, and with enough depth data point. And so we started to actually reflect on what was needed to be able to allow us to reach a stage where companies will be able to deliver such promises. And it appeared to us at that point that that problem was not a one-company problem. It was actually a systemic problem. And so we embraced the idea of building an ecosystem that we're going to be sitting behind a computing foundation, that we're going to assemble every companies in TechBio right now that want to use computing at the core of the product development to move and fasten the R&D cycle. Fast forward to last year, we had more than 300 startups valued at more than $2 billion and ranging from pre-seed stage to actual Series C. And we had companies actually spreading from drugs and therapeutics to food and agriculture, to consumer goods, and to chemicals and material. Among these companies, we have had tremendous, actually, companies. We have had companies being able actually to use plants as a way to produce electric vehicle batteries by using the simple idea that plants actually consume minerals out of the soil and turning these plants into factories that are going to be able to use the soil as a way to get out the toxic metal that we actually have in the soil to turn it into elements that can be used for the electric vehicle batteries. In the food tech, we have seen companies right now building and developing actually lab-grown meat and being sold now on a day-to-day basis more and more everywhere and even in brand commercial actually store chain. And we've seen in the consumer good industry, companies actually using lab-grown leather to be able to help the fashion industry address the sustainability issue that they're facing, helping them at every level of the layer. And so TechBio is actually here. It's actually here to stay, and it's going to be the most important paradigm shift that you're going to be seeing coming forward and moving around the way that we use product, the way that we actually produce product, but also the way that we consume them. And it's going to be one of the major trends that you're going to be hearing more and more about in the coming years. So thank you so